Everything is hostile until proven safe. That is the golden rule for today's explainer. Imagine building this massive, state-of-the-art fortress, but you just leave the front door wide open. Well, that is exactly what a huge percentage of generative AI apps are doing right now. By blindly assuming that internal data and retrieved context are inherently safe, they are leaving a massive vulnerability right in the heart of their architecture.
Welcome to the explainer. Look, our objective today is simple but absolutely critical. We have to unlearn some really bad habits. We're going to deconstruct the naive assumptions behind traditional retrieval augmented generation, and we're going to build a secure, zero-trust generative AI pipeline from the ground up. We need to start treating your RAG pipeline like a hard security boundary, not just some friendly search system.
Here is our architectural game plan for today. We'll hit the fatal flaw of standard RIG, introduce policy as the new brain, and then run a single adversarial query through our high-stakes security gauntlet. Then we'll cover sanitizing context, taming the LLM, and finally, establishing the new zero-trust reality.
All right, part one, the fatal flaw of RAG. Let's look at the dangerous assumption developers make when building AI apps. In a standard RAG setup, you retrieve data, stuff it into the prompt, and the LLM answers. It's kind of like letting literally anyone walk right off the street and board an airplane. Zero Trust RAG, on the other hand, is a strict TSA checkpoint. You retrieve, sure, but then you validate, authorize, transform, re-rank, and only then pass it to the model. Every single piece of context is treated as a threat until proven otherwise, period.
So why do these traditional systems just fail so spectacularly in production? Well, developers treat their vector database as trusted storage. They completely skip policy enforcement at retrieval time, basically ignoring multi-tenant isolation boundaries. But you know what the biggest sin is? Relying solely on the LLM's prompt instructions for safety. Telling an LLM, hey, don't share sensitive data is incredibly weak. Security enforcement absolutely has to move out of the LLM and directly into the retrieval pipeline itself. Moving right along to Section 2, Policy as the New Brain, Establishing Machine Enforceable Rules. The real paradigm shift here is policy as code. We're talking about setting up machine enforceable rules using engines like OPA or AWS Cedar. This shifts the whole concept of retrieval from just data access to access-controlled data access. Every single retrieval step is explicitly authorized, validated, and filtered by this policy logic, way before the context ever gets anywhere near the generation phase. And all this logic lives in the policy enforcement point, or PEP. Now, the PEP is embedded directly within the retrieval layer. It's not some optional add-on, it is a hard security boundary. It evaluates every single document and enforces per document allow or deny decisions, field-level filtering, specific redaction rules, and even ranking adjustments. It's basically the ultimate gatekeeper. Which brings us to Section 3, the security gauntlet. It's time to actually test these defenses. Let's set the scene. A user types show me internal incident reports. Right there, that's a real-world threat scenario, an attempt to access highly sensitive internal data through your AI application. Now, I want you to imagine, without classification, what happens next? In a standard system, the RAG pipeline happily executes a similarity search, scoops up your highly sensitive internal logs incorrectly, stuffs them into the prompt, and just serves them right up to the user on a silver platter. It's a massive, instant data leak. But a zero-trust solution completely neutralizes that threat, step by step. Before retrieval even happens, we classify the intent. Is this public info, internal docs, or sensitive data? The policy engine evaluates this against our rules, and the second it sees the sensitive nature of the query, boom, the policy explicitly blocks the request or kicks it up to an authorization layer. The threat is stopped cold before a single document is ever retrieved. All right, Section 4, Sanitizing and Re-ranking Context. Let's look at how we clean the retrieved data. Let's say a query is actually safe, and documents do get retrieved. This context sanitization layer gets ignored all the time, but it is absolutely critical. Keeping our airport analogy going, right? This is where TSA confiscates the liquids and strips away the weapons. For personally identifiable information, or PII, emails are masked, IDs get hashed, and names are tokenized. We also actively strip out prompt injections, literally removing malicious patterns like ignore previous instructions or exfiltrate data. And finally, we use instruction and data separation tagging, basically wrapping the documents so the LLM physically cannot interpret them as commands.
And get this, even after all that rigorous sanitization, we pass the data through a second security gate, trust-aware re-ranking. Because ranking is not neutral here. If a document is allowed but has low trust, its score gets heavily demoted. If it's deemed high risk, 0 score, completely excluded. We are actively shaping what the LLM will see based strictly on trust metrics. Now for Section 5, Taming the LLM. Let's talk about the orchestration layer. The surviving data finally reaches the LLM orchestration layer. But make no mistake, we are keeping this model on a very, very tight leash. Zero Trust RAG doesn't just hand raw freedom to the model. We use tool-first enforcement, meaning if a query is classified as needing a specific tool, it bypasses standard RAG entirely. If the user asks for the latest financial data, the system forces a call to the Finance API only. Security incidents, that forces a call to the CM tool only. The LLM simply doesn't get to rummage around your vector database for that kind of info. And for the data that does manage to make it through, we slam it with strict context budget control. We mandate the absolute maximum tokens per source, the max sources per tenant, and an externally enforced priority ordering. The LLM has absolutely zero free will here. It doesn't get to decide what gets included. That decision was already made by the policy engine. Finally, Section 6, the Zero Trust Reality, wrapping up our bulletproof system. In a Zero Trust reality, an auditability layer is totally non-negotiable. Every single decision, every allow, deny, redaction, and ranking adjustment is strictly logged. Sure, that's essential for GDPR and SOC 2 compliance, but it's also exactly how you debug retrieval leakage and run adversarial threat analysis. You have to know the exact why behind the system allowing or blocking a specific piece of context. Really, this all boils down to a set of grounded, highly realistic assumptions that every single tech leader needs to adopt today. You've got to assume retrieved text is untrusted, you have to assume embeddings could contain malicious content, and that metadata might be spoofed. Always remember, freshness does not equal correctness. And above all else, you have to assume that even your very own internal systems can be compromised. Which leaves us with this stark, super memorable rule of thumb for every single stage of your pipeline. Verify, then trust temporarily, then re-verify downstream. Security isn't just some one-and-done prompt instruction. It is a continuous, rigorous gauntlet. So, taking a hard look at your own architecture right now, I have to ask, is your AI pipeline truly secure? Or are you just kind of hoping your internal data won't bite back?